Hey everyone, welcome to The Explainer. So let me ask you a question. Why is it that you can spend an absolute fortune deploying a powerful, state-of-the-art AI only to watch it completely fail at simple, company-specific tasks? It's incredibly frustrating, right? Well, today, in our explainer titled Fine-Tuning AI Models for Projects, we are going to crack that exact problem. If you're a non-technical business stakeholder, it drives you crazy when your shiny new AI writes a generic, robotic email instead of matching your brand's unique voice, or when it just completely misinterprets your internal company jargon. The truth is, pre-trained base models are brilliant generalists. I mean, they've practically read the whole internet, but they lack your proprietary domain expertise. It's kind of like hiring an absolute genius fresh out of college. Sure, they're incredibly smart, but they know absolutely nothing about how your specific business actually runs. Okay, so here's our executive summary for today. We're going to start with the customization toolkit, map out the step-by-step fine-tuning pipeline, optimize that training process, tackle the hardware and pitfalls, and finally, prove the real-world business outcomes. Let's dive in. Section 1, the AI Customization Toolkit. Let's start by laying out the exact tools we have to fix our generic AI problem. As a data scientist, I often see companies jump straight to the most expensive solution without understanding the alternatives. So you really need to know when to fund a fine-tuning project over the cheaper options. Prompting is free and fast, which is great for one-off tasks. Then you have RAG, or Retrieval Augmented Generation. That is fantastic for dynamic knowledge because it grabs external data and drops it right into the prompt for the AI to read. But neither of those actually change the AI's core behavior. Fine-tuning actually alters the model's internal parameters. If you need a highly specialized writing style, unparalleled accuracy, or the ability to handle really complex edge cases, fine-tuning is absolutely your answer. I really love this analogy because it just clicks, you know? Fine-tuning is all about internalizing company culture, tone, and specific rules. You are taking that pre-trained model and giving it the rigorous, specialized corporate training it needs to become an actual expert in your domain. Moving on to Section 2, the fine-tuning pipeline. Let's see how this builds into our actual step-by-step engineering roadmap. This is a very predictable, linear execution pipeline that brings a model all the way from an open-source repository like Hugging Face straight into your secure production environment. You choose your base model, you prepare your specific data, you tokenize that data, which literally just means translating your text into numbers the machine can digest, then you train the model, thoroughly evaluate its performance, and finally, you deploy it. Now, the crucial point here is that data preparation is where the magic actually happens. A small, highly curated dataset of perfect prompt response pairs is infinitely more valuable than just feeding the model millions of messy, unformatted documents. You gotta clean the noise, standardize the formats, and construct conversational pairs so the AI learns exactly how to respond when a user asks a specific question. Section 3, optimizing the training process. Once our data is flawless, we enter the training phase, which is where your data science team really earns their keep. Before we run any expensive GPUs, we have to precisely tune what we call hyperparameters. You can think of these as the critical dials and knobs on a soundboard. The learning rate dictates exactly how fast the model updates its parameters. The batch size is how many examples it looks at before making an update. If we set these wrong, the model just won't learn effectively, and will end up consuming unnecessary, expensive compute resources. Amateurs will often waste that compute power using basic grid search, basically blindly and exhaustively trying every possible combination of these knobs. It is incredibly slow. But our strategy leverages Bayesian optimization. This smartly uses past results to guess the optimal settings, significantly saving us time and cloud computing money. I also want to briefly highlight adaptive training methods like population-based training, or PBT. This is cutting-edge stuff. It automatically evolves both the hyperparameters and the model weights by running multiple models simultaneously and copying the top performers. It virtually eliminates the need for tedious manual hyperparameter tweaking. Okay, Section 4, hardware, costs, and pitfalls. Let's address the elephant in the room here. Full fine-tuning is notoriously expensive, so how do we manage costly GPU requirements and avoid breaking the model? This is where LoRA comes in, Low-Rank Adaptation. It's an absolute game changer for enterprise AI. Instead of updating billions of parameters, which requires massive server farms, we actually freeze about 98.5% of the base model. We only train a tiny 1.5% adapter that sits right on top. This means we can train massive models on standard consumer-grade GPUs, drastically cutting our hardware costs and training time.
But look, it's not without risks. There are 3 massive pitfalls we have to avoid. First is catastrophic forgetting, where the AI becomes so hyper-specialized it just forgets basic general knowledge. Second is mode collapse. If we aren't careful, the AI starts acting like a broken record, generating repetitive, identical outputs for every question. And third is overfitting.
Overfitting happens when the model basically memorizes the training data instead of actually learning the underlying patterns, making it totally useless in the real world. So to prevent this, we constantly monitor the loss curves during validation. We use what's called early stopping, meaning we halt the training the exact second the model starts memorizing rather than learning. That is absolutely vital for project success. Finally, Section 5, Real-World Business Outcomes. Let's dive into the most important part, the actual ROI of all this engineering effort.
The real-world applications here are incredibly powerful. In healthcare, fine-tuning on proprietary patient records leads to highly accurate diagnostic assistance. In finance, models fine-tuned on specific regulatory filings excel at fraud detection. In software development, the AI can generate custom code that fits your exact internal frameworks. Whether you're securing sensitive financial data on local infrastructure or locking in your unique brand voice for customer support, fine-tuning just delivers unparalleled customization.
When we deploy a hyper-specialized domain model tailored exclusively to your daily operational tasks, the accuracy jumps exponentially. The performance completely outclasses any generic, out-of-the-box, pre-trained baseline. It really is the difference between an okay guess and an expert execution. So, I'll leave you with this provocative thought. In the rapidly accelerating AI race, are you content deploying a generic intern, or are you ready to build a hyper-specialized domain expert? The competitive advantage of a specialized AI workforce is massive, and fine-tuning is exactly how you get there. Thank you so much for joining me to break down this powerful strategy today. If you found this breakdown valuable, please make sure to like, share, and subscribe to The Explainer for more deep dives into enterprise AI strategy. See you next time.